Today, we're diving into a technology that could rewrite the rules of space travel as we know it. We all know trips to Mars or Jupiter take months, even years. But what if we could cut those travel times in half? We're exploring the Sunbird, a groundbreaking rocket concept powered by the holy grail of energy, nuclear fusion. Hello tech enthusiasts, and welcome back to the channel. Our current rocket technology relies on chemical propellants. They're powerful enough to get us off Earth, but their efficiency is limited. This means reaching distant destinations takes an incredibly long time. NASA's New Horizons probe, for example, took 9.5 years to reach Pluto. For human missions, these lengthy journeys pose huge logistical and health challenges. If we ever hope to become a truly interplanetary species, we desperately need faster ways to travel. This is where nuclear propulsion enters the picture. When we talk about nuclear rockets, there are generally two types: fission and fusion. Fission works by splitting heavy atoms, releasing energy. Agencies like NASA are actively developing fission propulsion, with plans for tests like the Draco mission around 2027. But the ultimate goal for many is fusion, the same process that powers our sun. Fusion combines light atoms, releasing immense energy and offering theoretically much higher thrust and efficiency. And a UK-based company, Pulsar Fusion, claims they're on the path to making this dream a reality. Meet Pulsar Fusion. This UK-based company also works on more near-term technologies, like plasma thrusters and fission engines. But their most ambitious project, developed over a decade in secrecy, is the Sunbird fusion rocket. Sunbird isn't designed to launch from Earth. Instead, it would be based at orbital docks, acting as a kind of interplanetary tugboat. It would rendezvous with payloads in orbit, and then propel them towards destinations like Mars and beyond. So how does this tugboat move? Sunbird utilizes an engine called DDFD, the Dual Direct Fusion Drive. This engine uses powerful magnetic fields to compress plasma superheated gas to trigger fusion reactions. The incredibly hot high-speed particles generated by this fusion are then expelled out the back of the rocket, creating immense thrust. As Pulsar Fusion's CEO, Richard Dynon puts it, in terms of what can be theoretically produced at exhaust speeds, fusion is king. So, how fast are we talking? Pulsar Fusion claims Sunbird could cut interplanetary travel times by more than half. Remember New Horizons' 9.5-year journey to Pluto? Pulsar suggests they could potentially do it in less than half that time. This could mean trips to Mars taking perhaps only a few months, making human missions to Jupiter and beyond far more feasible. It's a technology that could genuinely revolutionize space exploration and colonization. Now, you might be wondering, if generating fusion power on Earth still seems decades away, how can a company plan a fusion rocket demonstration by 2027? This is where it gets interesting. There are key engineering differences between fusion for space propulsion and fusion for terrestrial power generation. While reactors on Earth need to sustain a near-continuous output of neutrons, Sunbird's engine is designed to use deuterium helium-3 fuel, producing protons, and it only needs to fire in relatively short bursts. It's still an immensely difficult engineering challenge, but a different kind of challenge than the giant tokamaks being built on Earth. The fuel itself, deuterium and helium-3, is also fascinating. Deuterium is an isotope of hydrogen, relatively abundant in seawater. Helium-3, however, is extremely rare on Earth. Its most well-known potential source, the Moon. It's believed that helium-3, deposited by solar winds, exists in recoverable quantities on the lunar surface. This highlights the potential future importance of lunar resources. Widespread use of rockets like Sunbird could make helium-3 a very valuable commodity in space. Pulsar Fusion isn't just about Sunbird. As mentioned, they also work on plasma thrusters and are designing fission engines. CEO Richard Dynon emphasizes that the company has built a reputation for delivering real technology, not just concepts. This lends some credibility to their ambitious claims for Sunbird, though a healthy dose of skepticism is always warranted in this field. The 2027 target is ambitious because building a fusion rocket presents enormous challenges. Managing the extreme temperatures, millions of degrees, and pressures needed to initiate and sustain fusion is paramount. Creating and maintaining the super-strong magnetic fields required for plasma confinement is incredibly complex, ensuring the engine operates reliably in the harsh environment of space, and that the materials used can withstand these extreme conditions. The list of problems is long. If Pulsar Fusion can overcome these hurdles and be ready for an orbital demo in just approximately 3 years, it would be a truly monumental achievement. Pulsar Fusion isn't alone in the quest for faster space travel. As we've discussed, NASA and DARPA are working on fission rockets. There are also other companies and research groups developing more efficient plasma thrusters, like Hall thrusters, or exploring more exotic concepts like Vasimer. Each technology has its pros and cons. Fusion offers potentially the highest performance, but is arguably the most difficult to engineer. It will be fascinating to see which technologies gain traction in the coming years. But what if Pulsar Fusion, or a similar technology, succeeds? It would be a turning point for humanity's future in space. Making interplanetary travel more routine could make establishing permanent bases on Mars, mining asteroids, or sending robotic and perhaps eventually human missions to the outer planets far more achievable. It would fundamentally change how we explore and utilize the solar system. A technology like Sunbird has the potential to truly make us a multiplanetary species. So, to sum up, Pulsar Fusion's Sunbird rocket is an incredibly exciting concept with the potential to revolutionize space travel through the power of fusion. The promised speed increase is staggering. However, the ambitious 2027 timeline and the inherent immense challenges of fusion engineering demand cautious optimism. If they succeed, they will make history. If they fall short, they will undoubtedly provide valuable lessons for the next attempt. All eyes will be on Pulsar Fusion and the developments leading up to 2027. Alright everyone, that's our deep dive into the Sunbird fusion rocket. What are your thoughts? Do you think the 2027 goal is realistic? What excites or worries you most about the future of fusion-powered space travel? Let me know down in the comments. If you found this video informative, please hit that like button. And if you want more content on cutting-edge tech like this, make sure to subscribe and ring that notification bell. Thanks for watching, and I'll see you in the next one.